Okay, we're back now and talking about features that appear not to be subject to any grouping below the root node. And so these are features that are not in that top level node, but they're also not in any other large set of features like the major place node or the laryngeal node that we've looked at earlier. And so the ones that McCarthy mentions here are nasal and continuant. And so the idea here is that these features can pattern by themselves in processes. They don't need to take everything else with them because they're not in the root node, and they don't need to take sort of companion features, or they don't tend to take companion features with them because they're not in any other major grouping of features. So what do we see for these? Well, for spreading, we have postnasal hardening in the case of nasality, excuse me, of continuancy. Um, and nasal harmony in the case of nasality. So we looked at Guarani nasal harmony a little bit earlier in class. And so, for example, here's the simplified case of Guarani nasal harmony, where consonants here can be specified for various pre and post nasal contours. And nasality spreads in both directions from a segment that's underlyingly specified as plus nasal or minus nasal. So it spreads in both directions here. And yeah, so this is clearly going to be some kind of spreading of nasality. The exact details about how this works in Guarani are very complicated, but the idea here is that the output has entirely, the entire first section of this word is basically nasalized, and then the nasal span stops in the middle of this consonant. This is going to come out something like Narahindi, where everything here is nasalized up until ndui. Postnasal hardening is going to be spreading of continuancy, right? So we saw lots and lots examples of this in the Steriade paper that we looked at earlier. Here's one from Suku, where what you can see here is when this class 9 prefix n goes before a root that begins with la, that la hardens to a da. So it goes from plus continuant to minus continuant, and this is very, very common following nasals. You can even see this very clearly when you get fricative initial roots, voiceless ones here, because the nasal actually deletes after it's been prefixed before a voiceless obstruent, except it leaves behind these affricates because it has hardened that following fricative into an affricate here. So the basic idea is that the minus continuant features you're getting from a nasal stop spreads onto a following plus continuant consonant, and you get either total non-continuancy, total stopping, or partial non-continuancy, so affrication here. And again, that's going to be within the autosegmental framework, spreading of continuancy. It's not necessarily taking any other features with it. It's just turning a continuant into a non-continuant. What about delinking of nasal and delinking of continuant? Well, we have nasal delinking in the Suku data above, as well as several other Bantu languages. And so that seems pretty straightforward. So this is not only the spreading of continuancy from that nasal segment, but also the delinking of nasality itself from that segment. But delinking for continuancy, I don't have any really good examples for you of delinking for continuancy. McCarthy mentions a couple possible examples in his paper that seem to me to be not very common phenomena, and ones that are kind of maybe ambiguous or could be analyzed in a number of ways. So I would say there's not a ton of evidence for the delinking of continuancy by itself that's out there. And then finally, there's the OCP effects. What do we find for OCP effects for these two features? As McCarthy notes, OCP for nasality is unattested. We don't know of any language that shows OCP effects where you can have nasals, but you can't have two nasals in the same word or something like that. It just doesn't seem to exist. For continuancy, arguably you could get some phonotactic effects out there that look like they might be related to OCP continuant. So there are a lot of languages that allow, for instance, sequences of fricatives followed by stops, but not sequences of two fricatives. And so here's several examples of languages that seem to work like this. And this is at the beginning of a word here, at the beginning of a syllable. Here's some examples from Muniche, which is an Amazonian language. These are word initial clusters. In Muniche, you can get word initial consonant clusters of a fricative followed by a stop, as in chpapa, chtatini, or sta, but you can't get word initial clusters of a fricative followed by a fricative, like chfapa, chsatani, or scha. Right? These are impossible in Muniche. These are possible. One way of analyzing that would be to say that Muniche has an OCP continuant constraint, and that's why you're allowed to have plus continuant followed by minus continuant, but not plus continuant followed by plus continuance. So that would be a possible analysis of these facts. Again, I can imagine other ways of analyzing that as well. So I don't think this is totally unambiguous as OCP continuant, but that would be a possible way of analyzing that. So that's sort of high-level features that are underneath the root node, but not necessarily grouped in any other large constituents themselves, nasality on the one hand and continuancy on the other hand. And to make it clear, I'm going through both of these at the same time because they both have this property of being sort of isolated features, but the claim is not that nasality and continuancy together are a constituent. They're two separate single feature constituents in the feature geometry. So we looked earlier at the major place features and how they all seem to pattern together in a large featural constituent, but there's also evidence for a fine structure underneath each of those features within the place node as well. So in particular, we've talked frequently in this class about major place features and the minor place features that sort of accompany them, right? So in particular, there's lots of little details of constriction, shape, and location that seem to be sufficient for phonological distinctions, but don't necessarily pattern like major place features in the phonology. So each of coronal, labial, and dorsal is thought to have some dependent nodes in the feature geometry. And the dorsal ones in particular, exactly how these work is a very fraught issue that we're going to skip for the moment just because it gets too far afield into feature theory. And it has to do with dependencies between vowels and consonants is what makes this very complicated. So we're going to skip over that for the time being, but we'll look at some labial and coronal instantiations of minor place features. And these are going to be modeled as underneath the major place features within that feature tree, within the feature geometry. So labial has a dependent node for the feature round, and coronal will have dependent nodes for anterior, distributed, and lateral. So yeah, let's take a look at the argument for round being contained in the labial constituent. This comes from Cantonese, and it's going to involve two related but slightly different phonotactic constraints. So syllable internally, you see here what's banned in Cantonese is a labial consonant followed by a non-back rounded vowel, right? And so Cantonese has both back-rounded vowels like English, like o and u, as well as front-rounded vowels like and ü. So these are standing in, this umlaut one is standing in for the IPA character y, the ü, high front rounded vowel. And Cantonese has these vowels, but they're not allowed to appear following a labial consonant within a syllable. Right? So you can get labial consonants. You can get labial consonants before back-rounded vowels, but you can't get labial consonants before front-rounded vowels. So Yip is going to assume that rounded vowels have a labial feature just like labial consonants do. We'll see why in a minute. You have a second constraint in Cantonese between the onset and the coda of a syllable, that they can't both be labial. So again, you get labial nasals in Cantonese, you get labial stops, but you can't have a labial stop followed by a labial nasal within the same syllable, nor vice versa. Right? So you can't have two labial consonants in the same syllable. How are we going to deal with this? The basic idea here is that there's an OCP constraint over labial, and that explains why you can't have two labial consonants here. Right? this is banned by OCP place or OCP labial. Front rounded vowels need to be specified as plus round in the underlying representation because they're also front unrounded vowels, and because rounding on front vowels is marked, right, in some sense. And the idea here is that because the feature round is dependent on the feature labial, that is, it lives underneath it in the tree, you can't specify this feature for a vowel without also specifying that vowel for labial. And that means there's going to be an OCP effect with the preceding consonant. Why is that? Because in order to get this vowel plus round, we had to specify it as labial. Basic idea here is that plus round lives underneath that labial node, and so the only way to get that vowel to be round is to have it specified for labial. Once you do that, we know that the preceding consonant is also labial, and so this is going to be an OCP violation. Now, if it's a back vowel, on the other hand, so this is for front vowels, for non-back vowels, the claim is that for back vowels, they don't need to be specified for roundness at all, right? At least non-low back vowels, because default rules will fill that round feature in after the OCP has already applied, and therefore there won't be any kind of an OCP effect during the phonology. This is going to basically happen at the end of the phonology before it gets pronounced. If you're a plus back vowel in minus low, then you are plus round in Cantonese. And this is not phonologically contrastive. It can be filled in as kind of phonetic detail. For the front vowels, you can't do that because roundness is contrastive there. They have to be specified for round. Because they're specified for round, they have to be specified for labial because of feature geometry, and that makes an OCP violation. So this is a really sort of clever and intricate analysis of why both of these constraints exist in Cantonese. The basic idea is that this co-occurrence restriction is showing us that there's OCP for labial in general, and then we can get this one to follow if we assume that back vowels are unlike front vowels precisely in the fact that they have to be specified for round, but that will only work if round is dependent on labial. So that's how that analysis works. There's similar arguments for each of the dependents of the coronal place node. Here's an argument for anterior as a dependent from Chumash. This is an American Indian language. And Chumash has anteriority harmony or sibilant harmony. So what does that mean? Coronal stridents need to agree for the feature anterior. So you can have roots like osos, achish. I believe that, these are anterior strident affricates. So this one is tsa, and this one with the hatchik is going to be cha, and this S with the hatchik is a minus anterior sha. So this is going to be plus anterior sa, plus anterior tsa, sa, minus anterior sha, minus anterior cha, sha. This is actually their name for islanders, which is also the name of the language, Chumash. And these are fine as roots, but what you don't find here is a mix of, say, plus anterior and minus anterior fricatives. Right? So the claim here is that there's a spreading process. Similarly, you can have different kinds of inflection here. If we take this verb form, kishkin, and add a suffix to it that has a plus anterior strident in it, this us suffix, we see that the sibilant fricative in the root here changes from minus anterior in its underlying form to plus anterior. Similarly, we put on a suffix that has a minus anterior sha in it, and this root, which originally had a plus anterior tsa, goes to minus anterior cha. So this is interesting. On the one hand, we're going to say that within a word here, there's a process that spreads the anteriority feature from one strident segment to a preceding strident segment. Now, you might expect this to be blocked by other segments, because in our original theory, even a segment like, say, a labial would have been marked as minus coronal and minus anterior, right, or something like that. Or maybe actually a better example would be with a plus anterior segment, if we can find one of those. Well, anyway, this doesn't is not important. And the idea here is that you wouldn't expect to be able to spread a feature across another instance of that feature. In feature geometry, we can handle this by saying, well, if it's not a coronal consonant, then it isn't specified for interiority, and that's why interiority can spread across it, because there's simply no anterior node under this consonant, because interiority is a dependent of the coronal place node. That would be the basic idea here. Here's a spreading argument that anterior and distributed, these two features, spread together. This is from the Husenhoven and Jacobs text. And it's based on English coronal allophony. And so what are we looking at here? We're looking at all of the coronal consonants in English, and there's a lot of them. So there's these dental ones, the, and this is N with a little tiny dental diacritic under it, which is pretty hard to see in this handout. The dental diacritic looks like this. So that's the dental diacritic, and there is a little one underneath that n there. So those are dental consonants, and all of these are coronals, but those dental ones are plus anterior, so they're towards the front of the mouth, and they're plus distributed, meaning that they're made with the area just behind the tongue tip, with the tongue blade as well. Here's the alveolar ones, t, d, n, and la. These ones are also coronal, and they're anterior. They're made further towards the front of the coronal area, but they're minus distributed. These are really done with just the tongue tip. And then there's the post-alveolar, the the non-distributed and non-anterior coronal consonant r here. And there's also another diacritic under this T that's hard to see, but this is the post-alveolar ch consonant, right? And so these ones are going to be coronal as well, but they'll be minus anterior because they're further back in that coronal area, and they're minus distributed because they're made mainly with the tongue tip retroflexed. That's the basic idea here. And the claim is that when you put two of these consonants together, you get assimilation for both anterior and distributed spreading together, but of course only within the class of coronal consonants, because these are the only ones specified for those features, right? So the claim here is that in a sequence like in Rome, that you're getting retroflexion of this nasal before the retroflex consonant r. Similarly, all there, the claim is that this liquid l is dental in this case, all there. And that's because it's taking on all of the minor place features of a following coronal consonant, because again, those minor place features, anterior and distributed, are dependent on the coronal node and are going to spread between coronal consonants only. Similarly, the claim is that Inthersk is going to have a dental nasal, and that's from assimilation to the following dental fricative. Words like try clearly have a post-alveolar stop sound here, or affricate sound. This is not terai, it's try in most varieties of American English. So again, the claim is that those non-anteriority features are spreading from one coronal to a preceding coronal. This one I find completely bizarre and incorrect, but Clements apparently says that this is how American speakers pronounce get red as gets red. This is not possible in my variety, but that's what he says anyway. And so, yeah, let's just assume that this is some variety of English that isn't mine. And then also here in words like width, the claim is that this voice stop, to the extent it's present here, is going to be dental. So what's going on here? Well, again, we have a couple time slots. each one of these time slots is going to be associated with a root node. And that root node is going to dominate, a whole bunch of different things, including place, and down below the place, there's going to be a coronal node, and down below that coronal node, way down here in the tree, we're going to find all of the minor place features, including anterior and distributed. So for instance, in the case of, say, in Thirsk, where that na is going to be plus anterior and plus distributed, it's going to be minus distributed because it's alveolar. And the following th sound is going to be plus anterior and plus distributed because it's a dental sound. So this is the sort of input configuration. We have all of this very complicated feature geometric structure up here. And so I'm again shorthanding all of this. There's like continuancy and major and laryngeal nodes, and then there's somewhere there's the major place node. Down below that is the coronal node, and underneath the coronal node, contained in it, we have anterior and distributed. What's happening in these cases? The claim is that the entire coronal node here is delinking in that first consonant, just like most of the other assimilation processes we've seen. Sorry, I'm having trouble doing the delinking here. That coronal is going to delink, and the coronal node from the following segment is going to spread on over here and attach within the major place node of that preceding segment. So now we still have two segments, and they're still associated with different root nodes and different kinds of major class features, but they share a coronal node with all of its associated anterior and distributed properties. This is the claim here for the feature structure underneath the coronal node. So here's basically what we've come up with by looking at all these nodes. We saw evidence first for the place node that had labial, coronal, and dorsal underneath it. We haven't talked about radical consonants at all. There's a bunch of evidence for how these pattern from different Semitic languages, and we haven't really talked about the structure underneath dorsal here, so we're leaving these as question marks. There's probably stuff here, but we're going to skip it for now. What we did find is that this place node has a bunch of place features that all seem to spread together underneath it. And then each of those place features, some of them also seem to have a bunch of features underneath them that spread together. Over here we have the laryngeal node that operates independently from place, and it has, at the very least, voicing, constrictive glottis, and spread glottis. McCarthy adopts a particular feature theory about stiff and slack vocal folds that we're not going to use in this class, but that's basically standing in for voiced and voiceless here. And so we have this whole grouping of features, this whole grouping of features. We saw evidence that all of the features together, basically whole segments, can work as a single whole. That's the root node here. And we saw arguments that that root node contains sonorant and consonantal. And then we also saw these two sort of oddball features, continuancy and nasality, that seem to just pattern off on their own and do their own thing. And this is the basic picture that we end up with, is this sort of complicated feature tree. And now every single time slot in the phonology, rather than being linked or not linked to features in various ways, is going to be linked to a root node. And the root node is going to dominate or fail to dominate whole sets of features in this model. So we're getting more and more complicated in our representations, but the hope here is that we're hoping to explain why some features seem to pattern together to the exclusion of other features. And if we can get this right, then maybe we'll be able to explain what happens in spreading and delinking phenomena without wildly overgenerating. Here's what we haven't figured out so far, though, what we're going to move on to shortly. There's the fine structure of the lowest place dependence, so we haven't really filled in this picture over here. That's something we need to figure out. We have a few missing processes for nasality, so we couldn't find an OCP effect for nasality, and especially for continuancy. We did not see much evidence that the feature continuant actually patterns on its own, so that's going to be a big problem. We're going to need to update our theories of underspecification and of privative features and of feature filling operations. So I had to make reference to a whole bunch of ideas here, like universal markedness and fill-in rules and things like that, that really we haven't even introduced yet. And we will need to introduce some theory of how all of that works. And presumably there's all sorts of other issues with this model that I haven't even thought of or put in this handout. But the next thing we're going to do is shift gears to focus on a set of specific phonological phenomena that are related to the topic that we've discussed today. And these are possible dependencies between place and manner or stricture features. So in particular, in our next unit, excuse me, dangers of recording at home. So in our next unit, we're going to see some evidence, and this is from a J. Paget paper, but I will take you through that myself, of dependencies between spreading of the place node and things that happen with these other manner nodes, and especially continuancy, but also to some extent possibly other major manner features. And just to sort of give a heads up to where we're heading, we're probably going to end by needing to significantly revise our phonological theory, but we're going to keep the feature geometry for now and ask what the feature geometry can do for us as we're looking at the typology of phonological processes.